He was a true Renaissance man. He discussed geography with Ortelius, astronomy with Brahe and Kepler. When the great University of Bologna needed a mathematics professor, they chose him over Galileo. He was an intellectual superstar, sparring with Galileo many times over many topics, sometimes getting the better part, sometimes not, but always with strong arguments that resonated in Europe's top minds. So when one of Italy's top printers wanted to publish a new atlas, an atlas that would make people forget about Mercator and Munster, they wanted the imprimatur of Italy's greatest intellect. The call went out to Giovanni Antonio Magini. What came of this prestigious project and the genius intellect that fronted it? A comedy of errors in which virtually every cartographic flub imaginable in that age was reproduced. Every time I look at this map again, I see something new, something else that deserves a video of its own. Today, we'll look at the most striking blunder and how it came to be. Welcome to the Eye of History. Here we talk about maps, new and old, but mostly old. We talk about the history of the map and the history on the map. And along the way, we might hit upon culture, economics, technology, science, and more. If that sounds appealing to you, please like, subscribe, and share. It really helps nerdy channels like this one. A brilliant polymath like Giovanni Antonio Magini would not fall into a blunder without good reason. This time, his blunder was predetermined, based as it was on one of the most fundamental questions in physics. Why does an apple drop to the ground and a rock to the bottom of the pond? Ask anyone today the answer to that question and they'll simply say, gravity. But what is gravity? Modern science has an answer that requires several semesters of advanced calculus to even approach the study of. Our map was made centuries before concepts like fields and tensors existed. I should point out that even Newton only half solved the problem. He found a method for calculating the effects of gravity, but no mechanism for what it was. It was derided as action at a distance. So, how do you explain gravity in a way that made sense in Magini's time? The ancient Greeks had an answer. First, they divided all things to two classes, the celestial and the material, or in more Christian terms, the heavenly and the earthly. All things heavenly naturally gravitate towards the heavens. All things material naturally gravitate towards the center of the earth. There was more to the dichotomy. Left to themselves, celestial things naturally moved in infinite circles. Left to themselves, material things moved in straight lines that always came to a stop. Celestial things were eternal. Material things were subject to decay. So it was that all matter was constantly attracted to the center of the cosmos, that is, the center of the earth. However, not all matter was attracted in equal measure. Matter consisted of four, some said three elements, earth, water, air, and fire, and earth was the most strongly attracted to the center. Water a little less so, air even less, and fire the least of all. This corresponds exactly to our concept of density and explains almost all of the everyday phenomenon where we observe gravity at work. There were lots of details to work out, which kept philosophers busy for 2,000 years, but the basic idea was solid. In fact, there really was no viable competing theory before Descartes and later Newton. There was one troubling hole, though. If all matter was of four kinds, there was a general expectation that all four types of matter would exist in equal proportion. Perhaps not precisely, but reasonably so. There should be as much earth, as water, as air overall, though it could be distributed unevenly. In particular, there should be roughly as much water as earth. Now, everyone knew that the world was a sphere, of course, and obviously at the center was where most of the earth was. So the earth core was covered by a layer of water, like so. So much was obvious, but the problem was obvious too. In this world, where were human beings supposed to stand? The oceans would have to be close to 1,500 miles deep. Our little city, not to scale, here is completely drowned. Clearly the earth core couldn't be such a perfect sphere. There had to be a bulge in it large enough to peak above the water level, something like this. Our little city was saved. This pear-shaped model worked. Asia, Africa, and Europe together with a handful of nearby islands, were all the dry land the Greeks and medievals knew about. They were one big lump poking out of an enormous world ocean. The medievals elaborated on it slightly, creating the TO map. With all the land perched on top of that pear in one great circle, the interior seas forming a T to divide them, Jerusalem in the exact center. Theology demanded that the Christ should manifest in exactly that place, and both physics and geography were happy to oblige. In this video, I talk about this sort of map being a typical medieval schematic, but just because it is schematic doesn't mean it was not scientific in the modern sense of that word. This was part of a coherent, testable, or as they would say at the time, a probable model of the world. It cannot be emphasized enough how satisfying this scheme was. But there were just a few thinkers that were bothered by the pear shape. It seemed unbalanced. They proposed a modest change. Instead of one bulge, perhaps there were two symmetric bulges, balancing things out. According to this theory, there should be a second continent on the other side of the world, the Antipodes or Antipodes. Either pronunciation is fine. Whether this countercontinent existed or not was a matter of pure conjecture, although the general consensus was that it was unlikely. Churchmen didn't like the idea. If there was an antipodal continent, theologians were sure that it had to be uninhabited, cut off as it was from both the Garden of Eden and from the reach of Christ's apostles. There was good physical counter-evidence as well. Virtually everyone assumed that the equator would lie between the Antipodes and the known continent, but travelers like Marco Polo reported crossing the equator, thus proving that the known world isn't so confined. For the most part, the consensus was that the world just wasn't big enough for two supercontinents. And then Columbus happened, or more properly, Amerigo Vespucci, who after voyaging to South America a few years after Columbus became convinced that the shores he was exploring were not those of Asia. He was the first to present cogent arguments on the subject and, decades later, was rewarded by having the new continents named for him. But the Americas were in the wrong place to be the antipodes. So why does our map show an antipodal continent? A sort of super Antarctica that fills half of the Pacific? For that answer, we have to look at the map itself. Giovanni Magini is usually given credit for this map, but he really had nothing to do with it. And the publishers, the Venetians Battista and Fratelli, deserve the credit only insofar as they hired some nameless engraver to copy an existing map as closely as humanly possible. The credit truly belongs to a relatively obscure Neapolitan named Giovanni Lorenzo da Nogna, who is known for 3 books: An Exhaustive Study of Demons, a corresponding study of angels, published posthumously, and La Universale Fabbrica del Mondo, a nearly 500-page geography text that contained just a handful of maps. I found a scan of it online, but the quality was too low for Google Translate, and all I could use it for is to verify that my map is as close of a copy as you could possibly make by hand. Even the little bits of inset text were copied over exactly. There were no copyright laws in this era, and Battista and Fratelli's atlas is just one of a half dozen that stole da Nogna's work uncredited. The publishers cribbed virtually all their maps from various sources, and Magini's sole contribution to the new atlas was the text. Text which is almost completely unrelated to the maps it accompanies. Here, Magini's text reads like an old-fashioned reading primer. Quote, "A large part of the world, scattered in the vast and cruel Atlantic, the Western Ocean, remained unknown to the ancients until the year 1492, when it was first discovered by Christopher Columbus, a Genoese man of great spirit, astute intellect, and mean-versed in the art of navigation, under the fortunate guidance of Ferdinand, King of Spain." The entire New World is described in just 2 nebulous pages. Nothing is stated with any specificity or authority. Magini was clearly mailing it in for the paycheck. Same was true for the rest of the atlas. The maps were well-engraved copies taken from other sources. The text was perfunctory. I haven't been able to determine whether the atlas was a commercial success, but it contributed nothing to geography and was at best a moderately useful reference book. Actually, to say that much is being overly generous, because so much of what's on this map isn't real. I expect to make 2 or 3 more videos just to catalog all the mistakes, so here I'll just give some of the highlights. First, the many interesting Atlantic islands. I spot Icaria, Frisia, and even St. Brendan's Isle. All mythical, plus a few more that I'm going to have to research to figure out what Denania was referencing. Ironically, the islands in the Pacific can almost all be identified with real places, although this map isn't going to help you navigate to them. On the west coast of North America were the legendary cities of gold, but Denania wasn't completely credulous. These islands off the coast of Peru are described as follows. Quote, "Some people want islands to be here, rich in gold." It is one of 2 honest statements on the map. Here in the far north it says, quote, "Further north the regions are unknown." That sort of humility was not common among mapmakers in this era, but it helps underscore an underlying truth. Mapmakers like Denania did not set out to lead mariners or merchants astray. They were simply too credulous, too quick to accept the reports of explorers and scholars at face value. Some historians today believe that the mapmakers were creating the equivalent of clickbait to entice buyers. I'm not so sure. I think that rather, they considered that being overly inclusive was a smaller sin than being overly skeptical. And in an era of global exploration, that was likely true. The Pacific Ocean presented is much smaller than the ocean is in life. Partly, this is because the antipodal continent occupies a large chunk of it, but the main reason is that the longitudes on this map are way off. De Anania, as did every mapmaker of the era, relied on the measurements of the Earth made in Roman times by the great geographer and astronomer Ptolemy. Longitude is very tricky to measure, and Ptolemy misjudged the size of Asia by almost half, thrusting East Asia about 80 degrees closer to America. But it wasn't Ptolemy that stretched North America to about twice its actual width. That was a more recent mistake. The result is a Pacific that is roughly the same size as the Atlantic, which surely conformed with everyone's expectations. But we'll leave that for future videos. This map is such a rich vein we can't mine all the gold out of it at once. So finally to the Antipodes, this massive continent that takes up most of the southern hemisphere. This is not a speculative myth, created by the mapmaker just to fill space. De Ananian believed that explorers had touched upon the Antipodes at least twice. The details that we see here were taken from observations made by noted explorers, written in their journals. Look past the decorative mountains, there is real data here. We'll start here on the western side. It's easy to read the label, Nova Guinea, New Guinea. A bit of explanatory text tells us that a certain Andrea Corsali of Florence had described this land, naming it Terra Piccinacoli. Corsali was no mythmaker. He was a client of the powerful Medici family who explored Asia and reported back what he learned. It appears that Corsali only personally made it as far as India, but he managed to extract a wealth of information from the Portuguese sailors that he encountered. In 1518, he reported on the discovery of a large island, perhaps a continent, at the extreme east end of the seas thus far explored. Somehow the name got switched around, not by Corsali, but by later authors cribbing from his account. Terra Piccinacoli is a bad Portuguese rendition meaning something like land of small islands. It was a Spaniard that renamed it New Guinea. In 1545, a Spanish explorer, Iñigo Ortiz de Retes, provided the first thorough investigation of the would-be continent that we have much record of, and most of the features on this map are taken from de Retes' account. So this much of the antipodal continent is on truly solid ground. Let's look at another portion to the east. Here again, the area is plainly labeled Tierra del Fuego, and we have no doubt what was being referenced. Ferdinand Magellan first discovered the area in 1520 and traversed the straits that bear his name. At least one feature on this map can be traced to the accounts of that first voyage, Cape Deseado, but I believe that most of the details are taken from later accounts. What's strange about this depiction of Tierra del Fuego is that it's, well, huge. It stretches over 30 degrees of longitude, which at this latitude represents 1,000 miles. It's about 5 times its actual width, and longer than any island in the world save Greenland and, would you believe, New Guinea. Why the huge discrepancy? Well, let's start by noting 2 simple facts of navigation. First, until the invention of the chronometer, longitude was impossible to measure at sea, and distance was really difficult as well. A ship could toss out what they called a chip log, just a float on a rope, and see how long it took to play out. But any currents in the water would move the chip along with the ship, confounding the results. And within the Straits of Magellan, currents were a serious problem. Indeed, the straits were a navigator's nightmare. Tidal currents were unpredictable and dangerously strong. As in the straits, the Atlantic and Pacific tides collided in a vicious turmoil. The winds whipping past the icy mountains could shift in an instant, demanding quick work on the sails, which, with the rigging, were often rigid with ice. Shoals and rocky shores awaited to punish any mistake. Magellan's little fleet had to proceed with extreme caution, sending the smaller boats ahead to scout the route. So harsh it was that Magellan's largest ship mutinied and turned back to Spain. It took 38 days for Magellan to traverse the straits. Subsequent voyages were no faster. 30 to 40 days was the norm. We can forgive the author of his annals if the straits seemed 1,000 miles long. So again, in this particular region, our antipodal continent is based on solid fact, if understandably exaggerated. What is conjectural, then, is the connection of these two pieces, this long diagonal shoreline reaching from nearly the equator to the latitude 60 degrees south. It's this connection that creates our continent. That connection did not always exist. In the first part of the 16th century, we typically find maps showing Tierra del Fuego as part of a southern continent. Some map makers extended that continent to nearly touch New Guinea, but as far as I can tell, the first map to connect the two landmasses was the Denania map. What's striking is that, although Denania was not that highly respected and his book was somewhat obscure, this map was copied several times over and by map makers of considerably higher reputation. Moreover, Magini's version continued to be published for another full century, the final time in 1713. That's over 100 years after a Spaniard first circumnavigated New Guinea, and almost a century after a Dutchman succeeded in crossing the Drake Passage and rounding Cape Horn. After 1620, the antipodal continent could only shrink. Most maps from before 1650 still show a relatively large continent, but from that point on, more and more maps omitted it. The last map that I can find that shows it is from 1755, and on this map the idea has been reduced to just a suggestive line. The idea then completely disappeared from maps, not necessarily because people abandoned the idea of a polar continent, but because map makers were changing their attitude towards depicting such speculations. And so the story of the Antipodes ends until in 1820, when a pair of Russian explorers finally turned speculation into fact with the first sighting of Antarctica. Giovanni Antonio Magini's reputation easily survived the lackluster quality of the Battista Fratelli Atlas. In fact, Magini went on to produce one of the most important achievements in the history of mapmaking, the first comprehensive national atlas. I should say regional atlas, as the area covered was Italy, which was then hardly a unitary state. Mapmakers like Mercator, Munster, and Ortelius published atlases, but their map selection was always shaped by what they had available. They typically relied on a combination of sketches provided by their friends, copies of other published maps, and original work of their own devising. They didn't have a systematic program, and nothing like a national survey would exist until the late 18th century. Magini was not content with that. His atlas would be the first to cover an entire region with consistent, standardized maps, and the first to apply the principles of triangulation to every map. He began the work in 1594, and even though he had the backing of the powerful Duke of Mantua and several Italian governments, the project was fraught with production and financial troubles. It took over 2 decades to put together and was published 3 years after his death. So if this map is nothing more than an uninspired copy, we can be sure that it wasn't due to Magini's lack of capability. Unfortunately, this doesn't do much for the collectability of our map. Maps from Magini's own Atlante Geografico d'Italia sell for thousands of dollars each, whereas maps from the Battista Fratelli Atlas are not exactly in great demand. Most will sell for just a couple $100, pretty much the baseline for any 16th century map. My particular example is worth a bit more. Of all the maps in the atlas, this particular map is perhaps the most valuable, thanks to all the lovely errors it sports. And my map is a very clean impression, has excellent color, and is in fine condition. I would expect to see it sell at auction for $500 or perhaps a little more. Of course, I am not a professional appraiser, just a collector, so as always, take my opinion with a grain of salt. We'll see more of this map, so like and subscribe, and let me know in the comments what struck you as the most outrageous myth on this map.